It's Math Monday. On Math Monday, we do concrete gymnastics with algebra. These are equations that we use today, anyway, for when we're shipping concrete. This is for the ready mix provider. If the ready mix provider gets a design strength from the engineer, they have to then go and put a factor of safety on it, bump up that 28-day strength until they have a number of tests over a 3-year period to show that they can make a quality concrete. So the way that this formula works, it's based on your design strength. So let's say for a certain concrete, we have 3,500 PSI 28-day design strength from the engineer. We've used the concrete over a 3-year time frame, and we've tested the concrete, assuming that I'm the ready mix provider, and we've got 40 different sets of tests on that concrete mix design, very specific mix design to give us the strength and the other properties, and the standard deviation of that mix is 300 PSI. So using these two values, we have two different equations that we use to determine what the new design strength, the bumped up design strength, has to be, and it's based on these values. So we take that 3,500 PSI, there's a few sets of equations. This one is for less than or equal to 5,000 PSI. So we've got two equations to play with, and these two equations are going to operate the same way, where they're taking the design strength and adding some bump to it, and that's going to be based on number of tests as well as that standard deviation. So the first equation is that F prime of C, that design strength, times 1.34 times your standard deviation and a design factor, which we pull from a table with 40 tests. It's over 30 tests, so that design factor is a factor of 1. So 1 times 300. And then our second equation, we'll take our design strength again, multiply that standard deviation instead by 1.34. We multiply it by 1.33. And then subtract the whole thing by 500. And the idea is we've got to pick the one that is the greater of the two, and that is the new concrete strength that the ready mix provider has to produce whenever this concrete mix is being used and it's tested at 28 days. So using the first equation, our 3,500 PSI is added to 1.34 times our standard deviation times that design factor, which is a 1.0, since we have over 30 tests, we've got 40. That gives us a bumped up strength of 3,900 PSI and a little bit of change here. We'll say it's 3,900. For our second equation, we're taking that design strength, adding it to 2.33 times that same value, that 300 PSI times 1. Then we are subtracting 500 PSI for a total of 3699. We can round that up to 3700. And for the two, we're going to use the larger, which is 3900. So when we're designing this mix, instead of getting a mix out that's 3500 PSI at 28 days, we have to transport a mix that's 3900 at 28 days. Now, for a second, let's assume that that test did not equal 40, but it equaled goose egg. Instead of doing this whole stuff over here, we're actually going to add 1,200 PSI. I believe it's either 1,200 or 1,000 PSI to that. And instead of producing that 3,500 or 3,900, we actually have to get 4,500 or 4,700 PSI in 28 days. So that's it. If you have any questions, shoot them below. Don't forget to like and subscribe. You're awesome. Go concrete. Beat asphalt.